Morning, this is Bill's Never Ending Projects, and I'm going to start video 3 on where I actually fixed the radio, I think. So let me fill you in on what I've been doing. I'm going to have to point the camera just a second. Okay, I reordered that 35Z5, not the 35Z3. Mistake. I guess I should have looked closer at what I was ordering. Burnt one that got red plated. If the plate on top turns red, there's a plate in there. If that turns red, you get it all black up here, and it's called red plating, I guess. I'm new to this, but that's what I hear. So I got the new one in there, and then I red plated it, not knowing what's going on. That's where I just learned that term. The pilot light was out, and it takes 6 volts, and it takes it off of this so it doesn't get so much. The 35Z5 rectifier. There's the burnt one, there's the new one. I stocked these for pinballs. So let me get that in there, then I'll explain some more what I was doing. Okay, so let me stick this in. It's the kind with 2 notches on the bottom. They're straight across from each other. And you gotta push it in to get it out. That's why I couldn't get it at first. See if it goes in easier. Yeah, I got, and I squeeze this back together. Somehow. That's in it. I had written 35Z5GT bad, and I put for the 14V6 detector dual tube bad. So I don't know why I didn't order that one. One on the far end, because it's the last thing that happens. You got the intermediate frequency IF transformers and tube, and then finally you detect it, and it's the preamp for that audio amp. So this one is definitely in the red, and it does make all the tubes go because it's not shorted or anything. So since I put that in, maybe it'll stop that from red plating. But another thing that makes things red plate, I heard, was these the power supply filter capacitors. So maybe I should change all 3 of these. I got them, so I think I will. Anything to keep my new 35Z5 GT from getting ruined like this one and turning all black. But I've seen somebody that works on TVs, when they didn't have a rectifier diode tube, they broke the glass off and put a real diode on between 2 of the pins. I don't know if that's something I could do or I just gotta wait a week. Yeah, my cord, it's so good. Somebody must have replaced it at one time. I guess if I just watch this from red plating, now with this light bulb in, maybe I'll try it again quick, just for the heck of it. The isolation transformer, I plugged it in there, it down to 105, just for the heck of it. Now let's see if this bulb's going to burn right back out, or what. Well, it came on. Okay, let's turn it on again here. I guess this side. Just got to keep an eye on that. It's just normal right now. So what I was getting before, off where I didn't tape it, was I got nothing. But if this detector is bad, maybe that's what you get, is nothing. I mean, it's in the red. And I did order one. It's not like I didn't order one. It came bad. So I'll just overlook that and order another one from somebody else. I don't think it's supposed to be red on top. It's red on top again, so, and I hear nothing. So I gotta shut it off. No, I don't think it's supposed to get red on top. So it's red plating every time I turn it on. So I'll bring it back when I get something replaced. This is easy with the sheet. Here's my sheet, and these blue lines are so you could know where the key is quicker. So you got the heater on each side, the filament at 1 and 8. And I'm looking for the wire that comes, the ground coming from the 3 capacitor, the stuffed one. So it's going to come over here, so let's look. There it is, and there's the key, exactly like in the book. See, it's in the same exact spot to do with the case. So it's right there. So then all I have to do is count up so many and see where this black ground wire is going. Then I can just draw it. So if the heater is on each side of that pin, so this is I gotta look and see if this is 1 or 8, if this is, which one's 1 or 8. This one's 1. So that's 8, so then, if this is 1, that's 2, 3, this big wire would be coming over on 4. So 4, 3, 2, filament heater, 1. So 1, 2, 3, 4. So let me see what 4 is. You see it before I do. 3, 4. It's going to a grid 3. Okay, I said the back side of this this capacitor that has 3 of them in there. 1 ground for 3 capacitors, and it goes to pin 4 of the IF amplifier. So now I put some color into this. So it didn't make much sense before, but now that I went back and traced the ground, and so the reason that capacitor ground goes to pin 4, grid 3 or pin 4, is it's a ground. So that makes sense then. That was the easy part. It's all by itself. Only 1 wire's coming out of there. But this end, there's 3. So I'm gonna follow those, and then now I can add that 1 wire to the little pattern here. Put a name, the pin socket chart. There, so I added it. Now it goes down to pin 4. So I'm gonna do that off camera for the, you get what I'm doing. I'm gonna do it for these 3. And then when I come back, then I guess it'll be time to change it. Okay, the blue went to the middle pin of the oscillator transformer. Wasn't on here, I had to draw it. And the other 2 reds are going to go to the rectifier here. And look where the pin is. You can see it's right there. And so it goes into the corner. Same as it does here. So I'll follow those and connect these lines up. Then I'm going to decide which one got the lower cap, the blue or one of the two reds. A couple of 47s or something and a 20 or something. I didn't have to look any farther than the old capacitor case that's holding all three. It says the reds were the 40s and the blue was the lesser one, 20 microfarad. So that's what I'll do. I really don't even have to know. Those wires I cut off, which pin they go to, just so I follow it. But I'm interested in where they go. Well, I color-coded the electrolytics with these because they're all different voltages, so I could tell what they are. I made the blue at 25, the yellow at 30, and I don't know if this is going to be too big, but I only had in the 40s a red. I didn't have anything else, so this is what's going on. I'm going to try it. After all, they had a 40, a 40, and a 20. So, and it must have worked for a lot of years. So I couldn't use this band. It wasn't long enough. So I cut one out of a food can and bent it over there, and that should work. I put some hot glue on this one. First I tried to put all three up here, and I could see that wasn't going to work. Then I thought about putting them straight up and down like a radio and coming through those two holes right there and drilling another one, but then it would be near the rectifier. That would have been a hot spot for them. So then I came up with this. I could go all the way down in that one spot to the floor of the chassis, and then I put one over here. So now I just got to wire these up. That one being yellow. So the 30, and up down on the bottom must be the 25, and that's the 47. So, all right. Okay, when I was doing the rectifier doesn't use pin 1. As you can see, nothing's on it. Then here's 2, 3, and pin 4 and pin 6 they don't use, but then they use them to solder stuff too. See the 3 reds coming off this one? That's the hot, spreading it out through the radio. So anyway, I got these wired now, so maybe I'll try it just to see if the filter capacitors make the rectifier tube red plate. Let me see if got anything different. Okay, let's turn it on again. So, if I don't hear some static right away, see how that's getting real red right there? I don't know that it's not supposed to, but I don't like it. Still no static. Alright, well, I'm going to have to do some research to see if those paper capacitors have something to do with it, but I know probably I don't hear anything because the detector's bad. That's not going to be here for a few more days, so. So I guess I changed those filter capacitors, think it might do something, but I don't think so. My guess is something shorted. So I gotta find what's shorted, and then I think that's gonna change things. I'll have to look at somebody else's radio to see if that gets hot on top there. I don't think this plate's supposed to get hot, red. You're not supposed to see red in the middle. I'm gonna check some other radios if they show them with the chassis off. Alright, well, ends today. Try again tomorrow. Well, I spent a lot of time researching stuff, and I learned why my rectifier 35Z5 is red plating. It's because with this tube in the red, where it only on the tester, it's over in the red. So the filament only lights up dimly, so the filament is about used up, and it makes for more resistance. And I guess just that being screwed up, even though I got this lamp in there now, even this being screwed up, this acts like a fuse because they didn't put one in there. So inside the thing will heat up and wreck it. That's the only fuse they got, is you have to put in the whole 35WZ again. So having this bad will wreck this, or any one of these bad. There is no protection. No protection at all. So I've studied all day on how to put some protection on it. I found 5 ways to do it. That I could do some of them later. But one thing I'm going to do is make it so it doesn't run on 120 anymore, because these things weren't made to run on 120. Yes, with my isolation transformer, I could pick 105, but if I can build something in the radio, right in the radio, then that's what I'll do to keep it down. And I learned more about what I was studying, that darn domino capacitor, picofarad wise. When the antenna comes in from outside, it goes through RC filter. The R is the resistor, and it brings it. It brings the DC frequency that it gets from the natural air out there. It brings it to ground, and that doesn't take any of the RF coming through out of there. It just brings any unwanted DC, because I guess static electricity is DC. And so the RC, there's that resistor. So that's an RC filter. And the capacitor doesn't let DC in, because a capacitor is charging up and emptying, and DC doesn't, so it leaves DC in the dust. So any DC, the resistor brings it to ground. Because of the size of the resistor, it doesn't bother with the RF, a higher frequency. So that's a RC filter. And all the time I spent, I never really put 2 and 2 together what it really does and why it has to be there for the incoming outside antenna. Now for the loop antenna, it has one too. It's not in here. It's on the it's in the schematic. Ohmed out the IF transformer, and that one, IF1 and IF2. I was able to do that from following these wires. It says blue, red, white, green, and then over here on the other IF transformer, it was the same thing, or close. It's red, and up there it's blue. There it is. And over here it's green. There it's white. Found where the cans were up on top, and I found that they had these holes there where the wires come through. This one up here, it's 3 separate holes down in there. You can see 2 of them there, and one's up under there. So then I found where the pins come in, and some of these, Remember, I think I mentioned they're using pins that aren't used on, this has unused pins and this has unused pins, and they're using them for junctions. But eventually you find out where to put the multimeter on the ohms. And I got this. So it's supposed to be 29 in the red. I got 26.2, and it's supposed to be 23, and I got 20. This one's supposed to be 22. I got 21.5 and 20. I got 26.5. So they're the coils in the coils in these two is what I just measured. They're all right. This speaker transformer, it's called T200. Let me look on the parts, see what they call that. Under audio, it'd be under audio circuits. T200 output transformer. Give me any wire colors, so I guess you just have to spot it. Yeah, and that would just be the wires coming off this thing. Doesn't look too good, healthy, but hoping it'll be okay. I didn't get much of a reading, but 1.5. Says it should be 2. Oh, I probably had the wrong decimal point. It says 200 and I had probably 150. Let me try that again. First off, I don't know how to do it yet because it didn't give the wire colors like the other ones. You got, looks like a red and a blue. I mean, I can't do the wrong one, so if I did one of these and one of those, or if maybe you're supposed to do it that way, or if you're supposed to do these two, you got to do the right two or you don't get a reading. See, if I really want to get that without the wire color, all I have to do is find out what color leaves the audio amp 5085 tube. Leaves the plate on pin 2. It's a blue. I could write that on there. The color, and this one leaves, this is the one, there's 2 that come up from the rectifier for hot wires. This is one of them. Comes, so I can go back to where the filters are done and find out it's the one that comes off the sucker capacitor filter. That would be the one I made a 30. So I can go look at that and get a wire color. And I made it a yellow. So yellow comes off the capacitor. And I hooked it to that red wire and that red wire. Comes right to here. So now let me see. So on the rectifier, that's 876, pin 6. Here's the key, 876. Pin 6 is not used. They're using it for a junction. So since they're using it for a junction, and I come in here, it's that red wire going out there. That's the, so it's a red one. That one going out there is going to go all the way up to that transformer, I think. Check the primary on this, what was it called? Output transformer. So now I have 2 wire colors on the primary, the blue and it's a red. So I guess I can read one of the coils. Okay, I got this red one hooked to pin 6 on the rectifier, and I just have to touch this pin 2, so there's the key. So 1, 2, and there's the blue. So let's see if I get anything. 1.5. Turn this down. 1.6. Put it on 200. I get nothing. Put it on 2K. .6. Okay, let's see what that means, if it means anything. If I got 196 and it says 200, I probably got the decimal point in the wrong spot. Well, I do got it on 2K, which is 2000, and it won't work on 200, so it must be correct at 2000. So when I touch this, and it goes to 1600 ohms, that must be right. So that must be like an infinite amount to this, if it's supposed to be 200, so it must be open. But I'm not sure, because I'm not desoldering the wire. I'm not desoldering the wire on each end and then testing it. That's got to be why. Audio circuits. The speaker is right there, LS 200. And it doesn't list any ohms. Maybe it's in the service manual somewhere. I just wanted to tell me that it's a permanent magnet, but I guess it is. Because all they have is the output transformer that read 196, and that says 200. Add it to the 200. And I did the speaker on each side here and over here, and this time I got 4.6 ohms, and there are 4 ohm speakers, so maybe that's right. So I figure out where I got that 196. But oh well, I'm done doing home testing. So when I get that, this is that 35Z5 rectifier pin out. It's the tube. So I got it on. I got this on pin 3. This one is pin 2. Let's see what the reading is. 9.3. Okay, and then when I put it over here on pins, that's 3, 4 is missing, 5, 6 missing. I'm going to put it on 7. I get 27.8. Do my new one that I might have already wrecked, or I might not have. Okay, I got it on pin 2 again. So I touch it to 3. Not much different, and then I'm going to touch 7. That's different. So that one's 33 instead of in the 20s. So let's look and see which pins I just touched. It's the 35Z5 GT rectifier. And when I went between 2 and 3, and I got somewhere, what was it, 9 ohms or something, they both were about the same. Heater, so the filament inside the tube was connected. And I went from 3 to 7. Oh, it's the other heater. That's why I'm doing this. So that one's not broken. And the new tube is way up like 33. And this one was, the other one was about 27 or something. So whatever all that means, I did it. So that ends my ohming out stuff for the first time in a 5-tube radio from 1948. I've got one more thing here I can ohm out. The loop antenna inside the bakelite. I've got it set on 200, the lowest setting. We got 4.0. So just a minute, let me put this stuff away and we'll look at the schematic, see what it's supposed to be. This is what I just ohmed out. And it's supposed to be 2.8. And it was probably in the 3.8 or something, so it's up. I put 4, I didn't want to keep waiting for it to stop. So, that's good. So I just got to get that tube and we'll try it again, and then all those safe methods I found I can put on it. One thing, I got to switch the plug in there so the hot's on the switch. Then I got to put a fuse by the switch. So I just switched these 2 wires around in there. Put switch them around, and then the switch will be over here. And then put a fuse. And then I got 3 or 4 other safe things that I could put on it. If I do that and I buy them, I'll let you know at the time. Because if the factory's too cheap to put protection on it, so you don't got to use this for a fuse, that's the way they got it. Got to replace this whole thing for a fuse, and if every time you buy only one and you got to pay shipping, it could add up to $20 or more. So hopefully it's not bad. And when I get this one, then these will all come on brighter, and that will get dimmer. So till then, to you it'd be a second, but to me it'd be a few days. That's all I'm going to do, because there might be no dead short with those paper capacitors, even though I'm going to change them anyway. But I think this will brighten up. This will get dimmer and quit being red on top, and these will light up brighter, and as soon as I get this one out of here. Okay, sometimes I just gotta backtrack and review what I've learned, because I've learned about 5, 6, 7 things over the last day or so that I'm gonna include down here in a quick, hopefully just 5-minute update. So I'm gonna go up and use the camera against the schematic on my computer screen. Okay, some things I'm going to update on, possibly 5 things, were the floating ground and the resistor to the chassis, the 25 light bulb and the dim bulb, the coupling capacitor between the second to the last tube and the last tube, the using the voltmeter when I started up to read the volts on the plates, and depends on the tube if they're on the same wire line on the schematic. The floating ground and resistor to chassis. Then I have to go to the power section, 35Z5 GT, and here it is when you come out of the, remember when the 120 comes in from the wall, it's heating all the filaments. That's what that does. It's all AC right wall current, heating the filaments and lighting up the dash light. It's more or less to read the radio. Where it's on what station. So that's that. But we're over here to talk about the B+. The B+, if you didn't know what it was, is a DC voltage. They don't talk about B+ for AC. It's just B. And this is the one tube that gives. It's a cathode. Usually all the amped up voltage you get through a tube comes from the plate. In this case, with the rectifier tube, it comes from the cathode. And now it's that pulsating DC. And then when you get past all the capacitors, 1, 2, 3, you get, the C101A, C101B, C101C, you get not pulsating DC. So later I'm going to say to measure the current, when you start it up, you can either put it here or after. So you before where you get pulsating DC, or after where you don't get pulsating DC. And hit the mouse with the elbow. Okay. So and when you go to the B minus, it's going to be wherever the backside of all these capacitors come out. And then your this is on a floating DC ground. Yeah, all these backside of the capacitors come out to one wire, and they go to the floating DC ground. But then they have in my case, 150K resistor. This would read 150,000 ohms, but in shorthand, you do it 150K, and then it's to the chassis. That's not the real chassis mark. It should be like a rake, but that's what they're using. So that's chassis. After the resistor, this is B minus, this is B plus, B plus. So that's where you're going to monitor your voltage when you start up the radio. Somebody says the floating ground or B minus above the 120 ohm resistor, they mean right here. That's the floating ground. It's above the one. In my case, it's not a 120, it's a 150. I did the dim bulb tester and only ever had a 60 in it, but I heard tell that maybe I should start on a 25 and work my way up. So this might limit it more than a 60 or a 40. So the 25 watt bulb limits it more than a 60. I didn't even try these or never thought about it. So I guess the lower it is, the better it is at keeping things from getting wrecked. But then your tubes are not going to light up. So then you change it to a 40 and then a 60, and then your radio should be working with the dim bulb tester in the circuit. I covered this one using the voltmeter on the B plus and B minus for startup. And if two pins are listed on one ground wire, it means they're both tied to ground. It's in the 14B6. Right here you got pins 4 and 7 on one ground wire, which is actually dotted because it's the case of the tube or something base. So there really is no wire, but it's got 4 and 7 on the same one. It means they both go to ground on the same wire or tube base. Tied together. So pins 4 and 7 on the underneath of the tube would be tied together if there is pins 4 and 7. In this case, they're the cathode, which is the ground. That's what all these greens are, ground. And in this case, since it's only a 2-wire system, when I say ground, I mean common. Return, electrical return. Electrons return. And then the coupling cap between the preamp 14B6 and mine and the 5085 output tube. It's a critical capacitor. It's called the coupling cap. All these other ones got these transformers coupling. See, there's a tube, transformer tube, transformer tube. But the next one, it's tube, no transformer, because the transformer's got these wires. The DC gets dropped out because it's magnetically coupled. But here, you don't see any transformer between these two. Between the 14B6 and the 50A5, this is the amplifier, you might say, that runs the speaker. This is the dual purpose 14B6. It's the detector and it's the preamp. So they draw it in two circles. But you don't see any one of these between it. To drop out the DC cannot cross between here. So these last two stages, you see one here. That's the critical one. This one down here between the amp and the speaker, or the transformer that changes the impedance, it's called the output transformer. It just sets up the impedance correctly for the speaker. But that one's just a tone capacitor. That's not critical. This one's critical because coming off this plate, going to this grid, there isn't one of these. So they put C201 here. So that if C201 leaks, it's supposed to say DC voltage, that drives the grid, it drives the grid positive instead of negative. And so if that leaky voltage gets in here, this is positive B+, so it would change that negative voltage to positive, and it would burn out this tube. Just to recap, the oscillator and the tuning coil both make the normal station and the one that's 455 above. These work with the converter, and the converter sends out 4 signals. And when it goes into the Z301, we're in the IF section now. When it goes in here, only one of these 4 that come in are going to come out. 4 come in, 1 comes out, and that's the IF at 455. So all those high numbers, very high numbers, are only going to be left with the difference, which is a low number. And that gets sent to be amplified. On flow, heater cathode plate, that's the way it works in the tube. The heater warms the cathode, the hot cathode emits electrons. The plate is sitting on a high DC voltage, see, 90 volt, and it attracts those electrons. So the heater warms it, then the hot cathode emits the electrons. The plate has that 90 to 100 DC voltage, attracts the electrons. The grid is where your radio signal is going to come in, and it controls how many electrons get through. Then the tiny signal that's going to now ride on the it's going to now ride on the 90 volts. That it lets it through the grid. The tiny AC signal on the grid becomes a bigger AC signal at the plate. At the plate. That's the basic amplifier tube. I have the oddball tubes: converter, detector, and rectifier. The rectifier does not amplify. So what it does do, it takes AC from the line and spits out pulsating DC from the cathode. So all of them usually do something from the plate, but in this case, it spits out that DC from the cathode. There it is. That's the cathode, see, right? And that's where it starts your pulsating DC, where you're going to put your voltmeter red on the B+. This is now called B+. And then you put your black lead down here on the B-. Then the DC becomes the B+ for the whole radio. And on the other end of the filter caps is the B-. Now the converter, it's the 7A, 8 tubes in other people's radios. The tube mixes those frequencies together and kicks up frequencies. So the 35Z5 rectifier tube's not normal. It uses the cathode to produce the first DC electricity in the radio. It's pulsating current until it's filtered. This one, that's an eyeball, and this one, they still use the plate and the cathode and everything, but this puts out a mixed signals, 4 of them, and this one puts out a detected AC radio, and this one amplifies it. So this one detects it to normal radio audio, and this one amplifies it. And then there's so these two are kind of weird, but they still use the plate, cathode, and grid. They're not real weird like that one. And then you got the IF amp and the 5085 output tube. That's just normal. So now, knowing all this stuff on this radio, like Mission Impossible, if I decide to take the job, I'll have to fix this radio now, knowing all this stuff, through 2 videos that are 2 hours long and partial video of the third one, this one, where I'm supposed to be fixing it. But I guess I still needed just a little bit more tweaking in my mind of how this all works. Now I just explained it, so I must know it. So now that and my other tube come for the detector, so that might keep the other one from red plating, so I'm going to go get those tubes and open them up. I bought 3. I don't know why. You come down to see me? I'm just getting started. The difference between these old car radios, that have the 2 tube output tubes, those are, that one was a 980, 745. I wrote it more clear there. With the push-pull, 6v6. To cover ours, I'm using the 49-500, but I got a 48-200. Because what's the code, 205, has 2 different tubes. So I use the 49-500 instead. So it's called a single-ended Class A audio amplifier. Single-ended means only 1 tube. It's a 5085. Class A means the tube conducts all the time. So the single-ended Class A, the single-ended Class A audio amplifier is always revved up when idling, using more electricity when no signal's coming in. And so it's a single-ended Class A. Class A's conducts all the time, and then audio amplifier. Its only job is to take the tiny audio from the detector and make it strong enough to move to the speaker cone. So my old Buick radio is a push-pull. It's got 2 6v6 tubes. 2 6v6. You'll find them in all those things. How push-pull works. The audio signal is split into two halves. Positive of the waveform of the signal and the negative. This is done by a phase inverter tube, but in my case, it's done with a transformer. Phase inverter, it's not a tube in mine, but in others it's a tube. Whether it's a transformer splitting it or not, one signal goes to the push, one goes to the pull. Know that I never put two and two together. It's actually pushing the speaker cone and pulling the speaker cone. When one tube increases current, the other decreases it. The output transformer combines the two halves. Talking about my radio, but that's the output transformer on this Class A audio that we have. So that was the last thing I never brought up about what they call the output. So now I went into it. There we go. Here's my tube. I ordered 3. I guess I'll start cutting it open. It was the 14B6. So this one will be coming out. An electric, I guess. 14B6, 11, 12.6, 11, close enough. 12.6, there. 2. 2 and 3 up. 2 and 3 up and 1, 4. 1, 4 and 7 down. Okay, so that's everything correctly. This is kind of an important one. Voltage, but put this thing in there. I forgot which one it goes in. It's that one. Okay, I'm going to pause this while it warms up. Let's see what I got. Oh no. It's as bad as the last one. That's right. I went into the original one that's inside of here, and it didn't have a 2 there. It had a 1. So I put try only 1. Let's try that. First, hit this one more time. Nope. Okay, let's try 1. That's a little better. Oh, I found out why the 14B6 has those there. This is a dual purpose tube, so I guess to check the other side of the tube, I do this setting. These are all the same, so I guess I could try pulling a 5 down. And put it on 1. Well, I already put it on 1, so let me put 2 and 3 up and put instead of 2 and 3, put 5. Now we're checking the other side of the tube. Oh. Let's go to the next one. At N2 again. Here goes. Didn't do anything. The shunt got turned down. So maybe it'll do something now. Oh, I guess that shunt really matters. Man, they won't go out of the pad. Let's try the other side. It's at the 1. Just try it with the 1, because I put maybe try 1. Doesn't do nothing on 1. Oh, hey. But it's still bad. Okay, so let's change the 2 and 3 to 5 and then a 6. So the 2 and 3 to a 5. Okay, it's on a 5. And then a 6. Oh, the third one checked about the same as the second. I think I'll try the second one. Maybe it's a tube tester. But I took one out of here and put it in the other one and they tested. I mean, I can't test these kind, but I took one with that base and put it in the other one which accepts these, and it was the same. Back to the accurate instrument tester, accurate 257, and I've got to have it on F for filament, and then G and K will be 5 and 8, so I got it on F, G5 and K8, and then the load is 30, and the socket is number 6. And look what I got for the first time. A good one. And that's the one I thought was bad. Now let's try the one I bought. Unless I mixed them up. Say 35Z5, but they don't have the GT, but the GT I think is just for glass tube. I must have had one of these. I highlighted it this time across. So that means maybe since I didn't highlight it, maybe I put one of these on the wrong one, and then I never needed one of these 35Z5s. So it's on. I can't wait here. Well, it's hot. Let's see, it's on. Okay, here we go. Wow, this one is good as the other one. Okay, so the 35Z5 is not my problem. Get a good reading on this one and the other tube tester, so maybe it's a tube tester. I just read this for the first time. This is for pin straightening. So why I was ever trying to put something in those, I don't know. It's just the ones that are numbered here. So these kind don't go in here, and this is the one I paid I paid $150 for this tube tester, so this tube tester works. So, but I can't put those other kind in here. If I could, they wouldn't be in the book because it isn't made for those. But it did say these were either in the yellow or good. So then it must work, otherwise it wouldn't have said those are good. But then how come I tested 4 of these, buying them from, I guess I bought all those from the same person. Would he really shove 3 in there that don't work? I don't think so. Why would he do that? So it's the detector. I could at least check to see if it's not red plating. Oh, but if this is bad, it would red plate. That's right. I'll have to figure out. On the 50A5, you can see pin 4 and 5 are not used, but they're using it for a junction box. There's a blue wire coming from the detector from pin 2, and it's going to hook to pin 4 here, and then this resistor brings it over to pin 3. This replaces a wire, I guess. So then they just have a blue wire coming from pin 2 and hooking here, and then this brings it over to pin 3. What it does show on these little troubleshoot things where there's less wires, it shows my coupling cap C201, that if this is bad would wreck the amplifier tube 5085. So I was just looking for where that is. I found it. It's that one right down there. But there's that blue wire that comes off of pin 2 over here, and it runs up to that other box. But this one here is one I was looking for when I noticed that. I brought it up is because on the schematic, even though that's just a real short wire and the resistor has no wire at all, here's what it looks like on the schematic. See this resistor that doesn't show it going to the pin they don't use, because they just use that for a junction, so it's the same as just having a... So instead of having, they're showing 2 wires, they're showing a wire and then the resistor and then another wire, when in reality it's just one long blue wire. And a resistor in between it, so there'd be like 2 wires. So instead of a short wire, that's the way they did it. All the way down here in the schematic and back up. Where in reality, it doesn't have all that long. All that is 5 or 6 inches from here to here. So, yeah, that's 5 or 6 inches. So I guess the radio I chose to fix has a dead short to start with, and so when I changed all the electrolytics, nothing changed because it had a dead short to start with. And I changed the coupling capacitor to the 50A5, and that didn't change anything, and there's a few paper ones left, and I guess everybody says it's the paper capacitors that get moistened after 80 years or 70 years or whatever it is. Yeah, probably 80 years, and then they dead short. So because the paper becomes conductive. So I guess I could either pinpoint exactly which one it is. There's only, I'll show you how many paper ones are left. And counting the Black Beauty Bumblebee, that's just a paper one covered up with plastic. So we got 1, 2, 3, 4, 5. So it's got to be one of these 5. 1, 2, 3. This is an absolute different one. That one there kind of looks like a dog bone or something, but it's a capacitor that's got a bunch of markings on it. It's the only one like it that I know of in there. And then I got, like I said, those 2 over here. So that's 3, 4, and 5. Yeah, so there's only about 5, so which one is it going to be? I'll bring it back when I start. I also had to learn what ohm readings mean, because if I'm going to start on pin 8 of the 35Z5 rectifier, and then put one probe on the B minus here, and one probe here, and keep moving it out further. And if I keep getting a low reading, which I should right off the bat, I'll show you the first one, and then I'll just keep working it further and further up into the radio until I find a normal reading. So I'll bring it back when I do the first one. It should show not hardly any ohms, somewhere between 1 and 10, because it's shorted. It's been shorted all along, and I just didn't know what was going on. I have to drain these electrolytics first, the 3 I put in there, or I'm going to wreck my meter probably. So I'm going to drain those now. At least a 10,000 ohm cap. It said yellow, so 4 zeros. So I drained them, and so now I can start ohming. Okay, I got the other probe here on this green one, and it's going to the B minus right here. And here's pin 8 on the rectifier. So I touch that, we get our first reading. Nothing. Let me change this. Let me go up. Nothing. Nothing. So that's what you're supposed to get when you get a short. If I touch the two leads together, I guess the wire has a resistance of 1. But so that means the probes aren't broken or nothing. So again, I touch that pin and I get hardly nothing. So I'm going to keep touching points till I get a big number, and then I'll know where the good part starts. Did exactly what I wanted it to, because I didn't think my short was in my caps I just put in. So now I got to go past the caps unless it's a resistor, because here's the rectifier, and I checked it here, here, and here, but there is a resistor, and if this was shorted, I suppose. Then I could just check that by just going over here, because if it's still bad over here, then these were not it. So I'll just go over here to this last one, the 20 UF. That's still bad. What the meter does, it gives it a small signal for it to come back and give a reading. And so when it's shorted like that, it doesn't give much of a reading. Going all the way up to the highest setting, just in case I don't know something. Oh, now I get a reading, so I just didn't have it on a high enough. So it's 1.2 mega. That's like infinite. Well, I'm just starting to do this. I've never done this for troubleshooting with an ohm meter, so I'm pretty sure that's an infinite number. I'm in the millions, or whatever meg means. So I'm going to find out on the internet what that means if I get a reading way up there. Be back. Well, I guess the test I did, putting this higher and got the ohm reading that I did is showing that the B plus has no short, I guess. But this 47 I put here has got to come out. I guess it works the rectifier higher. Since I'm having trouble red plating, I got to take that out. It used to be just a 30, a 25, and a 20, so I got a 30 and a 20. So the 47's got to come out. There's a 22, but it's not an axle. So that, so it's such a good job at it too. Oh, can't believe I just got to put a smaller on it. Okay, the 47 back out of there. I was almost just going to cut it off because I had them all twisted so nice, but I stayed with it and unsided. So now I took out the 47 and put in a 20, or what was it, 20 or 22, I can't read it anymore. But it's lower than what it's supposed to be, but if it raises heck with the tube to have it higher, at least now it's not. Okay, changing that out from a 47 to a 20 did not stop this from red plating. So now I'm going to take the wire at the last spot that sends it to the radio, and I'm going to take the solder off and see if that stops it from red plating. That would mean that the problem is up in here somewhere. I found that I lifted the leg of this resistor and was measuring it. This is only supposed to be at 220 ohms, and it's two tied together, and it gave me some mega ohms, and then it fell apart. So this must have been shorting out the this is what's shorting out the rectifier tube, maybe. So I'm going to get those out and then get another one in there. Okay, that one there is brown, red. So that's the 1200 ohms resistor, and the one I cut out would be the 220, so I got to find a 220. See what I got. These will handle 5 watts, and 22, no, 4700. 22. Five of them. Okay, I gotta dig it out. I think these would be a little big. I see they're all that big because I bought 5 watt ones instead of half a watt or a watt. So I wonder what watt's supposed to be on a radio. Maybe I'll use the internet. I don't think my part book tells me. But if there's no reason I can't use one of these, maybe I can bend these around. Maybe. That's all I got. We'll see. These are brown, black, yellow. Brown, black, yellow. So 1 for the brown, 0s for the black, and I guess the yellow means 4 zeros. So that's 1 meg. These are 1 meg resistors, so I guess. I just never read one that had, I didn't know that the multiplier could be on the 4th color. I'll have to check that, but I used an ohm meter, and that's what these are, 1 meg, so I guess you can have a 4th color, and it'd be the multiplier. Put these on an auction, so let's see what's in here. That's where those 1 megs were. These are obviously picofarad ceramic capacitors, I guess. Now, 10 picofarad. What do we got here? 560 picofarad. I didn't even know I had these. And looks like 1 ohm. Well, let me stop and check one. Look at how tiny they are. These wouldn't be enough wattage. Those are way too tiny. Let's go back further in the book some. Same thing, real tiny. Oh, they're up to 18K. Okay, I can't use those. Okay, so I got it set on 2K because it's 220, so over the 200, so 219, it was on 220, so I don't know why the decimal point's there. Should be on the other side. I'll take it because it says 220. It's not like I've read any resistors in my life before with a multimeter. Maybe 1 or 2 somewhere. Okay, so this is the only one I got. It's just overkill, so I'm gonna bend the wires and get it in there. It's getting up to temperature. I better get this soldered. So while I was waiting for it to come up, I was counting these before, and I thought I'd just seen a few, but it's 1, 2, 3, 4, 5, 6, 7. So there was 7. Well, I pushed it over here. So now I would just have to get from there to there to there. But I'm crossing over the top of these, so it has to be a covered wire. Let's see what I can find. Okay, there it is. I got it down to the pin 8 to pin 6. There is no pin 6, but pin 8's where the hot comes out. So then they have this resistor hooked to the extra pin 6, and then this side here probably comes off of pin 6. There it is, it's the other red one. So they just use pin 6 for anchor, or like what that thing is, solder light. So the pin 6 has no use, so because the rectifier only has, where's one? Here's one. It doesn't have all the pins. So now let's see if it'll work. Just shrink tube stuff away. Be right back. I just tried it. I'm able to read that thing in circuit. I don't know if I can do it with one hand, but there it is. In circuit, it still reads the same. Which means you can check it in circuit without pulling one lug. And the switch there, and that's going through the isolation transformer, so yeah, it's on. Okay, you can tell this highlight a little. At least I can tell. It looks good. It's not red plating anymore as far as I know. Let me turn it up to about 90. Still red plating, I believe. There it is right there. Let's get it turned back down. Now, since it's still red plating, I want to unhook this hot wire right here. So it can't go feed any of these all the way across. But it isn't like maybe it is that simple, but this is what I see. The hots go to all these. It goes to the converter pin 6. It goes to the oscillator coil, the 2.5 ohm side. It goes to the output transformer, but that is a different wire. The hot goes to the first IF cam transformer. The hot goes to the 14A7 pin 3 grid 2. The hot goes to the primary coil of the second IF transformer. Hot goes to pin 5 of the 14B6 rectifier. The hot goes to the 14B6 plate. And the hot goes to the fake pin 4 and then the pin 5. That's how they work in the resistor 470K. So which one of these is the main wire? Which one of these is the main wire leaving? That's what I have to figure out. So with these jumpers, they use these resistors, jumpers, this is the rectifier, pin 6, pin 4 are used for junctions. Here's pin 4, this is the biggest junction. This sends at least 3 off it. And the way they get their power is through a resistor, right here. And then when it gets to this one sends a resistor over to that one. So then your power is coming out 8, 6, and 4. And 4 also sends to the oscillator, and then the oscillator sends it to the tuner. Because they're all hooked together right there. And that's where I found a short. Right here, this wire was up there touching that, and right there you could see one barb sticking right out that was stuck to that. So maybe that will quit making a red plate. Probably try it again from finding that, but maybe it was never touching or something, and it's only one strand, but that's probably all it takes. It still was. I shut it all back down. Yeah, it's on off. Okay. So back to, so what I'm trying to do is, I want to find one wire I could just cut or desolder that would see if it would quit red plating, because one wire I thought would send it everywhere. So, but if they got it spread out, where it could be this one, that one, or this one, so maybe it'd be a little harder than I thought. Well, with this oscillator wire that feeds it up here, and then the one leaving also has 90 volts, obviously. And if it was touching that one, then this could be fried. And I did get kind of an ohm reading from this one. I mean, it's got 2 coils, look like any transformer, but I couldn't get anything from another side. So if this is shorted, this could be shorting this. So all I have to do is pull the number 6 junction here, the red wire coming up to here. So I'm going to pull that. Well, there's that wire. I pulled it off the oscillator, so I'll let you know if it quits red plating. I'm sure it won't. I've got the variac way down on what is it on 60? I don't want it to red plate. It's not right now. And it's making some noise. It's the first noise I've ever got. I got the speaker covered up, but so I guess should I try giving it a little more? I mean, I unhooked the power to the oscillator, so it's not red plating, but that's because I'm on 60. I'll turn it up to 75. So then that was the short on that wire to the oscillator, and it probably burned out the oscillator itself. Oscillator transformer, I mean, sorry. One of these are the real oscillator tuning coils. When I unhooked that wire and I flipped it around, I knocked the breaker out because I forgot to cover it up. But I don't know. I'm going to make sure it's not red plating, and it's obviously not going to work if I need a new oscillator transformer. So that ends it for today. Okay, I put the 90 volts back onto the oscillator transformer, and I've taken, this is the 35Z5 rectifier, this is the converter, so this is the I-off, and I counted around to pin 6, where there's the key, and so I counted around, and 1, 2, 3, 4, 5, 6. This is here. I'm hitting the grid of the IF, and we're getting static. So we're getting somewhere here. So this proves that the amplifier stage is it's just not getting any. It's not getting any. This is not mixing in the 455 higher so that it puts out the sum and the difference and the station. The sum, the difference, the station, and the 455 above the station, that's what's supposed to go to the converter tube. So if this is not working, all that's not going here, and this is going to filter and only pass 455, and there isn't one. So when I touch this grid to the IF amp, it makes noise, meaning it works. So it's got to get that. It's got to get that 455 IF signal, and without getting that, it's silent. So if this is not bad and it's good, I'm thinking about changing. I'm thinking about changing the R400 and the C402. That's the two that have to do with the oscillator transformer. There's one here, and there's that one there. So those two, I could change those, and maybe that's stopping this from working. Everything cranked up on 120. That's on 120. And this has a switch also. It's all the way over. So now the light is bright. Maybe I wasn't putting this on enough juice to hear the static, but that's what I did when I touched that grid. But I'm still not hearing any static. So the oscillator transformer is not passing anything. And when the red plating is stopped now since I fixed that short, that red point in the middle there, that's the pin that holds the filament up. I guess that's supposed to get red. So let me change that resistor and that capacitor and see if the oscillator transformer comes alive. And it's possibly wrecked from that short. Up this tube, I measured it with this measurement device. It was up on 220. I shut it down. That one's still on 190. So the amplifier tube and the power supply rectifier were in the 220 degrees. That can't be right. So it's got to still have a short in it, a shorted capacitor or a transformer or a resistor, or a wire touching still. So back to work. Okay, this is my first time going through it. So when I thought the tubes were hot, I thought I was melting or doing something, but I guess they say the tube is going to get warm like an incandescent light bulb. It's probably about 13 watts in one of these, especially these two, the power amp one and the power supply. They've probably got about 13 watts compared to an incandescent bulb, and it's trapped inside this glass. So it's going to get hot like an incandescent bulb. And so they said that's the operating running temperature. 220 is about average, anywhere from 200 to 300. So I guess I can continue. Rectifier tube, the new one I bought, I can turn the glass and this a little, it's loose, so I guess I'll have to glue that. The internet said from tapping on the grid of the IF amp, it proves the IF amp works, the audio works, the power supply works, the speaker works, the rectifier works, the filament chain works. I've narrowed it down to the oscillator farad, and the radio test that I'm going to do. Said take radios, put them both side by side, working radio maybe halfway up, so loud enough to hear the change, and put it around, this is AM, around there, and slowly turn the non-working radio across the dial, I guess with it turned on, and it doesn't have to be turned up, I guess, because this is the one you're going to hear it on. So I'm going to do that test. Quit turning it to 120. These are made to run at like 117 or 115. So I'm going to leave it at 115 from now on. It's off, right? Yeah. That's right, and I'm also thinking right now the 1487, right there, was the one that didn't check good in the tube tester, I think. So the one I don't have an extra one of. So, yeah, so all these tubes this is the only one I didn't get an extra one for, and it's the one I actually need. So that's probably all it is this tube is bad. So I'll do the radio test anyway, but it Probably not the transformer then, even though it was shorted. Those things are hand wound and built to last, so I guess I'll have to get another one of these so I could switch it. Oh, I was wrong there. It's not the 14A7, it's the 14B6, I guess it was. That's the converter. I do have an extra one of those, so then I could do a test where I switch them, but both of them read bad. That's what it was. Okay, stain with rust on it, 14A7 IF amp works, because we just proved that by tapping on the grid. So that's good. So let me do this test. Well, I wondered where I'd get a small radio to put side by side. I don't have a transistor radio, so I went out to the single digits in the garage and dug this out. It used to be a garage radio I used 15 or more years ago. So I gotta let this warm up before you can plug it in or it'll wreck it. Capacitors could break or something. So in the meantime, I guess I'll do something else. Well, I guess then I can come in here and run my train around. Alright, I got one car track, the inside, that'll go around now. I haven't used this for several years. Wiped out down there. That dump was the lap counter over there, right here. Now it didn't make it. But what good's the lap counter do on the other side where I can't see it? Oop. So that's what I'm going to do while the radio's warming up. I have another track. I have to get the electrons flowing, and then I don't know. It's set for a few years, so now I got it so I can use it again. Sure, which one I got set up? That's an Aurora 1970 with a Camaro. Train I got there. It's a Dale Earnhardt. And that's a couple more of the Aurora sets. Down there I got, says an Aurora from 68 to 71. Possibly I got two sets put together to cover the whole 8-foot sheet. And I had to make a stand to put the transformer on. There's an old dehumidifier that's broken, and then I put an electric cooler from Pilot truck stop on it that I used to use when I was trucking for the top. And, well, I'm going to go back in there and work this newer track they have. It's got 3 rails. Isn't that weird? Keep the little pins in here and stuff for the Aurora track. So this is the kind that I used as a kid, HO. And so that's the one I bought back from using eBay. Trying to use this amp thing. Amp what? kilowatt, volts, 123 in the house, amps. So let me plug that radio into it to see if it's pulling anything. I think it's, yes, it should be on. I guess on. At least it says it's on radio, AM or FM. I get nothing. So I'm trying to see if it's pulling anything. .1 watts or 7.2 watts. Zero amps. So what's that mean? It's dead? Maybe it's a cord. Let me find a different cord. I've already taped it once, but that should be. It did say it was pulling what? 1.1 watt. Now let me shut it up. No amps. 1.1 watt. Let me change this. I think the amps should have said something. I think it's dead. I'll have to find a different radio or figure out if I can get a different cord and try it. That's the cord. I'm getting just 5 volts. Well, there it is right there. It's broke. Clean off. I don't know how, it must have barely been touching to give it 5 volts. So, I'll have to strip this back. Well, I'm going to slide these shrink tubes up and then see if the radio will work. Okay, so I'll just take it here to make sure nothing pulls on the connection. It's working. All the tape buttons were stuck and the motor kept going. Finally got it to shut off. So now I got it on AM. Okay, so the tubes are lit up now. Let me put this back up to where it's hissing. And let's turn this. There it is. Experiment's over. The oscillator's working. Next up, change the 100K resistor in the oscillator section and the 47 picofarad capacitor. Here I go. Okay, so this one's hooked to the oscillator. Oscillator right here. Oscillator transformer, that is. And so I took a very long time to learn how to read these, and now I'm good at it. So I have to identify that I'm looking for a 47 picofarad capacitor and a 100K resistor. So I know this is the capacitor because I learned how to read that. That's black, yellow, and purple is violet. There is no purple. And then violet 7, so it's supposed to be a 47. So so when you come down here, black 4, and black means it's that code, which is what they call that there, Jan code. The A is Army and the N is Navy. So you skip the black, that just tells you that it's that Jan code, Jan, and then yellow is 4, and violet, the violet is 7, and then the multiplier is 0. So 0, it's 0, so you don't add anything. So it's 47, so that's the one. That's the one that I gotta take out, and I gotta go find a 47. So what it is, 47 picofarad is like very small capacitor. See what I got? I watched Jeff yesterday when I put on my ohms meter. It kept taking juice till I removed it. So I would think it works. Yes, that capacitor's still good because I was kind of testing it yesterday with the multimeter, but I searched, it must have been an hour or more now, and I finally found out off the 50A5 speaker amplifier, this resistor right here, coming off that pin. It's coming off pin number 3 because that's the key right there. So it's just 1, 2, 3. So it's right there, and it comes down all the way down to another tube, and it's right here. I drew it. So it's coming off pin 3, and it's going down here, and it's supposed to be 100K, and it only measures 28.8K. That's what's keeping the radio from playing, because you can't have this that far off for it to work. It has to be a certain voltage, so that's way, way, way off. 100K, 28K. So I'm going to get rid of that right now if I got one. I was wrong. There is an actual 27K resistor, or 270K or whatever. It's 27,000, so 27K. So that was wrong, but I did find it. I'm going to show you where it is. Here it's on the converter, pin 4. Comes out and goes down, and it tees off and goes to that. So the way it is actually on the radio, this is a ground. At least from here to here is a ground. I don't know what it is from here to here, but it goes from pin 4, grid 1 on pin 4, to cathode, which is a ground. Cathodes are all grounds, so that's the way it looks on that. Goes from here over to there. That's the way they have it. Some rifleman up on MeTV, but other than that, I've been looking for this for 3 hours. Here's why I never found it. Look where it is. If this is the rectifier, this is the converter, this is the IF, and the detector. So this is the converter. Now we're going to zoom in. Or try. That's it. Down in, it's almost next to the center pin there. See it? It's between those 2 pins. So the orange wire goes to pin 5, so this is pin 4, and that's where it cuts over from. And it goes to the cathode at pin 7. So you can see it cutting over there. Skipping pin 6. That's the green wire. So that's pretty well hidden, I think you'd have to admit. So now I gotta see if I got one and change it and see if the radio works. I've got it lifted right here, one end's loose. I'm gonna take a reading, but I turned it on the back side where you could see the colors better, and it's the right one. It's a brown, black, yellow, and yellow would give it, brown gives it a 1. Brown gives it a 1, and black gives it a 0, that's 10. And then 3 zeros, no, yellow is 4 zeros, so 4 zeros. 4 zeros make 100,000. So that's so that then is 100K. So that's the right one. So when we get the reading, it's 100,000. I put it on 200K, and just a second, touch them together, make sure I get 0. Yes, and here goes. I got 113. I was hoping it was bad. 113 could mean 113.6K, and it's supposed to be 100K, so 13,000 off. Is that enough to make it not work right? I'll have to check the internet. So again, I only got one of these big 5-watt ones, so let me test one of these and see if it goes way up to 113. I got it on there. I took some coating off of this. Looks like, I don't know, 16 gauge wire. And I put it on each side, and it's there. Will the radio work now? Though that capacitor I didn't change yet, so sounds pretty quiet to me yet. Well, maybe it's the capacitor shorted. The one circle does block everything coming in there from the loop. Let's go for that one next. Well, I still have to cut that domino out of there, but that one end is cut. You can see the wire. So with the one end cut, I went and put one of those in there. I don't know what you call them. Instead of a 47, it's a 50 picofarad, because I read the domino and that's what it was: black, yellow, violet, black. So it was a 47. So now it's a 50 picofarad. So these are the kind that people said, oh, you never have to change those. So let's try it. I'm going to hook to this. The loop antenna is way over there, so let's just hook. That's my antenna I installed a few weeks ago up in the house. It's after 6 o'clock, so now if this radio is really good, we will get a little something, because on that radio, after 6 o'clock, I cut the power, and it, you know, you could tell it's still there, and you get the signal, but it's nothing great at all. So try one more time. The ground, it follows this around and goes to this, and then goes to the chassis right there. Right there. Okay. I guess the Variac's still on 115, so here we go again. Okay, so it's my first song. The reason it was on the station is I reenacted it. I wasn't going to tape nothing, and I stayed later past 6 o'clock, and I changed that capacitor just to see what if, and it worked. So I reenacted it coming on. This is all you get after 6 o'clock. So it should be loud and clear tomorrow, so until then. Okay, I'm going to remove the cardboard from this speaker, and we'll do our test this morning. It's definitely after 6 o'clock a.m. Well, it's been a while since I put that on. Time I hooked the ground from the antenna, not to the chassis, but above the 150K where it floats resistor. Otherwise it goes through that resistor. Maybe that'll make a difference, but let's see. It's on 115. That sounded very good. There's only one station will ever good. Yeah. So I guess I got more work to do on it. That sounds terrible. Okay, I just looked at the 46 radio that I have from somebody to work on, and this blue wire, instead of hooking an antenna to it, is right here to this screw. So I put that there, and then I see the antenna wire is not hooked to this by the tube. It's hooked over here. So there's two of these things sticking up, one on each gang, or one on each. One of these is the oscillator, and one of these is the tuning capacitor. I put it on this one because that's where the wire of the loop went on the other one, and then guess what? Still needs this ground. Okay, I see what's going on. I finally got my first normal sound when I first turned it on. Last time I had it just idling it just above shutting it off. So this time I've cooled it off. So there's still a problem, but at least I got normal volume for a few seconds. So here goes again until it gets hot. Until it gets hot, it works normal now. So now I just got to figure out why it dies after it's hot, or do some more testing. I'll bring you back when I figure something out. But obviously, well, I thought this was the outside antenna hookup. But so let me see if it's just that. Let me hook this back to here and see if I get the same thing. No, that's the terrible distorted sign. So, put it back up.